Okay, we're going to be solving the integral of root x squared minus 9 over x squared. The way we solve this is by noticing that we have to do a trig sum. In this case, it's going to be the secant that we're going to invoke because the constant is what's being subtracted from the variable squared. So you have x squared minus a squared. So what's a? It's 3. You take the square root of that. So x equals 3 secant theta. Now we take the derivative because we're going to have to replace the dx. The derivative is 3 secant theta tangent theta d theta. Tangent theta d theta. Now, notice we still can't replace everything because we have the dx, right? And we've got this x. What's x squared by itself? Well, it's just x squared. So if you square this, you get 9 secant squared theta. That's what we're going to replace. So we're going to replace everything here . X was 9 secant theta. No, it was 3 secant theta. It's 3 secant theta, but I'm not going to show the step. So it's squared. So it's 9 secant squared theta minus 9 over 9 secant squared theta, and dx was secant theta tangent of theta d theta. So now we could do some canceling here. So this is just secant theta. We get rid of this. And so we have a much simpler version in which we just have tangent of theta and the 9 outside, the 1/9. 1/9 outside. This right here can be factored. I don't know why I deleted the tangent of theta. It's still there. So you factor out the 9. It's factored. And it's going to become a 3, but I'm going to go ahead and show the steps. So you have 9 squared of theta minus 1, like that. So then this becomes a 3, because you're square rooting. When you square root a 9, it becomes a 3. So 3, fuck. 3, this becomes 1/3, 1/3. Now here we're just left with this, secant squared minus 1. This is what we wanted, so now we can make the substitution and make this tangent squared of theta. We're making this tangent squared theta. So if you take the square root of tangent squared of theta, you're left with just tangent of theta. Multiplied by this other one, it's tangent squared of theta. So you have tangent squared of theta. You got the d theta over here. This is a 3. Now we can convert to sines and cosines so stuff can start canceling out. So when you have this in the denominator, because this is just 1 over cosine, but it's in the denominator, so you're multiplying cosine. Cosine of theta. And this is sine of theta, sine theta squared over cosine squared. Sine theta squared over cosine squared theta. So this cancels, and you're just left with a single cosine theta. Okay, now where do you go from here? Well, you can make a u substitution. You can make a u substitution in order to solve this. So go ahead and do that. So we have, or it might be easier the other way. Maybe if we just have 1/2 sine times cosine. Or we can do, you know what we can do? Okay, I see now. We could do, replace that back with the cosine squared. Cosine squared theta minus 1. And this was secant theta, right? This one was secant theta. Secant theta, d theta. So now we can multiply this out. We can multiply this out, and that's how we solve it. Because if we multiply this out, you just get cosine of theta, because remember this is 1 over cosine of theta, so it cancels out with 1, and you're just left with cosine of theta minus secant of theta, d theta. Now we can take the integral of both of these, because by the linear property, or whatever it's called, because now we're not multiplying, but we're just subtracting. So that's good. We can finally solve this problem. So what's the integral of cosine? The integral of cosine of theta is just sine of theta plus c. Right? We'll leave the plus c for later. Minus the integral of this, which is natural log, absolute value of secant theta plus tangent theta. That one's a little hard to memorize. But yeah, you have to remember that the integral of this is this. And now we could do the replacement. The replacement, because remember we changed to thetas, but we need to actually have this in terms of x's. We need to have this in terms of x's. So now we have to go back, and we had x equals, remember what we replaced it with was 3 secant of theta. Why was it 3? Because that's the square root of 9. So now we have to solve for, we have to use trig stuff. We have to use trig stuff. We have to use a triangle. Secant of theta. What does this mean? This means on a triangle, if you remember, secant is the inverse of cosine. Cosine is opposite, no, it's adjacent over hypotenuse. Is adjacent over hypotenuse. So this is the inverse of that, which is hypotenuse over adjacent. Hypotenuse over adjacent. So x and 3. This means, by the Pythagorean theorem, that you have to do, fuck these mosquitoes. Okay, 9 plus something squared equals, maybe not use x, use y, equals x squared. So we want to solve for y. So y equals x squared minus 9 square rooted. So that's what this equals. It's the opposite side of theta. Okay, now we could just plug this back in. Now we have everything. We have all the sides, so now we just take what we need. If we need sine of theta, what's sine? It's opposite over hypotenuse. Opposite over hypotenuse. This is the opposite. So, root x squared minus 9. I'm going to rewrite it because it was too far away. X squared minus 9. Opposite over hypotenuse is what we're going to replace sine theta with. X squared, that's just from geometry. That's just something, if you don't get the whole opposite over hypotenuse, that's just something you should have learned in geometry. There's sine, which is opposite over hypotenuse. There's opposite over hypotenuse, pointing to the wrong thing. Tangent, which is opposite over adjacent. And then cosine, which is adjacent over hypotenuse. And secant is the inverse of cosine. Cotangent is the inverse of tangent. And cosecant is the inverse of sine. So, minus natural log of secant theta, okay? Secant theta, as I just said, is the inverse of cosine. Cosine is adjacent over hypotenuse. That's 3 over x. So the inverse of that is x over 3. And tangent of theta is opposite over adjacent. So we're adding square root of x squared minus 9 over 3. These take kind of a long time. But yeah, that's the final answer, plus c. Plus c. I forgot the plus c. Okay, there we go.